All right, I'm going to give a quick tutorial on how to write formulas for ionic compounds. So to get us started, we better talk about what a compound is. So you guys, this compound, right, we're really familiar with. You guys know water. Well, water is made up of more than one atom, at different types of atoms. It's got 2 hydrogen atoms for every 1 oxygen atom. So you can see that ratio right here. This is 2 hydrogens for every, and there's a hidden 1 if there's no 1 written as a subscript for every 1 oxygen. And so H2O makes a compound called water. Now, water is a covalent compound. Water is made up of hydrogen and oxygen, which are both nonmetals. Okay, so 2 nonmetallic atoms combined, or multiple nonmetallic atoms combined, will form covalent compounds, and we're going to talk about covalent compounds next week. Okay. But if you have, say, and I know Mr. England's video, he gives the example of table salt, sodium chloride. Sodium is a metal, and chlorine is a nonmetal. And if you don't remember how to determine that, maybe you could look back at before Christmas break. I know we covered some of the metals versus nonmetals. Metals are found on the left side of the periodic table. Just let my pen reconnect. Oops. And nonmetals are found on the right-hand side of the periodic table. Okay, so you can determine this. Now, sodium and chlorine combine again in a 1-to-1 ratio. Okay, 1-to-1. And we call this a ionic compound. And that comes from the fact that sodium and chlorine, okay, will either gain or lose. Metals like to lose electrons. Nonmetals like to gain electrons. Sodium, when it loses one of its outer electrons or its outer electron, it forms sodium ion with a 1+ charge. And chlorine, which has 17 electrons, likes to complete its octet rule by gaining 1 electron. And so when it gains 1 electron, it forms an ion with an extra negative charge, so 1 negative, because it has an extra electron compared to its protons. And then the rule for writing ionic compound formulas is their charges of both ions, the metal and the nonmetal, need to come out to sum to 0. So they need to be neutral, I guess you could say, or you're going to combine different amounts of each ion until you add up to a total charge of 0. So in this case, +1 and -1, you combine it, that makes sodium chloride, okay? In the case of, let's say it's calcium phosphide. So calcium, and I'll show you where you can look these up. Calcium likes to lose 2 electrons, so it forms a 2+. And phosphorus, okay, which is a nonmetal, likes to gain 3. So when it gains 3 electrons, it becomes, its charge is -3, and we call it phosphide. So calcium phosphide, to combine these, I need to come up with a way to make a neutral compound. So if you guys think of least common multiples, the least common multiple of 2 and 3 is 6. So by taking calcium 1, 2, 3 times, okay, so 3 calciums, and then phosphide once, twice, that's 2, right? 3 minuses. I end up with a +6 and a -6 for my ions, and I would write this chemical compound all together as Ca3P2. And what that means is I had 3 calciums and 2 phosphides, so my ionic compound is calcium phosphide, Ca3P2. Okay, or we could try one with, let's go with potassium sulfide. And we'll show you where to look these up. You can look up what are called oxidation numbers or common charges of ions on this periodic table, and we'll provide you one. Let's see if I can get this. Okay, and I'll highlight in here. So we were doing potassium sulfide this time. So I find potassium, potassium's K, And you can see it likes to be K plus, meaning it likes to lose one electron. Its oxidation number is +1. So potassium, K plus. And then I go find sulfide. Well, sulfur is going to be on the other side of the periodic table, right? Non-metal. Sulfur likes to gain 2 electrons. So its oxidation number is 2 minus. And I always write the charges in the upper right-hand corner. And then to combine these to make a neutral ionic compound, it looks like I'm going to need potassium twice. And looking at this, +1, and a -2. I need 2 positives to add up or cancel out the -2 charge of the sulfur. And I'd write my chemical formula as K2S. 2 potassiums for every 1 sulfur. Now, just to show you guys what this would look like in terms of its Lewis structure, we did Lewis dot diagrams before. Potassium, even though it's element number 19, the first 18 electrons fill up its core, and its 19th electron is on the outermost shell, its valence shell. And sulfur, which is in group 6, right? This is 2 groups away from the noble gas. It has 6, even though it has 16 electrons, 10 of them are on the inner shells, and 6 of them are on the outer shell. So if I go 1, 2, 3, 4, 5, 6, you're like, well, sulfur looks like it's too short of a full octet. So if I have 2 potassiums, what can happen? I can transfer some of these electrons. So if potassium, if both of those lose their electron, that leaves them positive, right? They're down 1 electron compared to the protons that they have. And if sulfur gained 2, now it has a 2 minus charge, and you'll notice that, right, plus, plus, and -2 sum to 0. So I write potassium sulfide as K2S, and I balance those charges. Okay, now some funny things to note, you guys. It's pretty clear in group 1. All of them have +1 charges. In group 2, +2. Right? Group 3, +3. Okay, group 4, there's no real charge. These are going to be involved in covalent bonding, especially carbon. We'll talk a lot about carbon next week. Group 5 likes to gain 3 electrons. Group 6 likes to gain 2. Group 7 likes to gain 1. And group 8, these are our noble gases. And noble gases don't like to bond to anything. So, like helium, neon, argon, krypton, those just like to hang out as atoms by themselves. So when you blow up a helium balloon, okay, each little particle in there, if you could zoom in on one little particle, this would just be a helium atom with its 2, and I should draw it, right? It's element 2 with its 2 valence electrons, and helium, right, is happy with only 2. And if we were to look inside a neon sign, right, and you've got neon, oops, I'm going to do 2 shells of electrons, 1, 2, 3, 4, 5, 6, 8, 9, 10. Just a quick reminder, neon is happy because it's already got a full octet of electrons. So it's not looking to gain or lose. So you look at your, the open signs or the cool old school kind of, bright red neon. Those are individual particles of neon that are being excited, okay, and forming a neon plasma inside there. And you get that characteristic red glow. So, anyways, that group 8 doesn't like to form any type of bond, typically. In the middle, in the transition metals, you're going to see some funny things. For example, this is a good one to talk about, iron. Iron, okay, this is weird. Sometimes it likes to lose 2 electrons, other times it likes to lose 3. So if we're writing chemical formulas, let's do iron chloride. We'll do both forms of it. Let's start with iron 2+. Well, if it bonds to chlorine, and chlorine, right, I can go look it up. Chlorine is in that 1-, likes to gain 1 electron. it's going to take 2 chlorines, okay, to bond to it. So when I write the formula for iron with a 2 plus charge, it would be FeCl2, okay? But, oops, my pen just went crazy. But if I write a different compound with the iron with a positive 3, where it has lost 3 electrons, and given them to 3 chlorines, right, 3 chlorides, then this would be FeCl3. Now, these are 2 different compounds with different properties, and we would have to name them differently. So it turns out, and we talk more about this if you go on to take chemistry, which we hope you take chemistry at some point in high school, this would be called iron 2 chloride. And this guy would be called iron 3, and I use Roman numerals, chloride. And this 2 matches the charge. So that Roman numeral tells me I have an iron with a 2 plus charge, and this 3 tells me I'm talking about an iron with a 3 plus charge. So certain metals, okay, like iron and cobalt and nickel and copper and antimony and lead and tin, okay, all these with multiple oxidation states, you have to kind of specify which one you're talking about, okay? The other thing I want to talk about is something called a polyatomic ion. So here I've been dealing with, say, iron and chlorine, 2 different elements, okay? Or when we did potassium and sulfur, right? Potassium sulfide, or calcium phosphide. I was dealing with 2 individual elements for those ionic compounds. But there are some cases, like this case, this cluster of atoms, and there's 4 atoms there, 1 nitrogen and 3 oxygens. That's called nitrate. Okay, well, potassium nitrate, so I'm going to write this out. So here's potassium again. Potassium is usually K, but it likes to lose its outermost electron. So potassium nitrate, which is used in gunpowder, its chemical formula would be 1 positive ion, right? And this whole cluster of atoms has a negative charge. So I would need 1 positive potassium with 1 negative nitrate, and I would call this thing potassium nitrate. Okay? Now, what happens if, we're talking about a different ionic compound with the same, this is called a polyatomic ion. So I should list this as oops, come on, pen. I guess Mr. England and I were both having problems with our pens in our video. Okay, so that's a polyatomic ion. If we do the same polyatomic ion, so nitrate, but this time I pair it with calcium, so calcium 2 plus, and NO3 minus. In this case, I need 2 nitrates to balance out the charge of the calcium. Okay, so to do this, I would need 1 calcium and 2 nitrates. And I group those, the nitrogen and the 3 oxygens together, that nitrate, I group them together in parentheses, and I put a little 2 outside showing that I have 2 nitrates. Okay. Now, nitrate is not the only polyatomic ion. There's a whole bunch of them. You can look them up. We'll provide you with a list. Some of them, most of them involve oxygen. So, like, for example, sulfate is SO4 2 minus. Okay. Carbonate, CO3 2 minus. Let's see, what else? Oh, here's a funny one. Ammonium. NH4 plus. So if I wanted to write the chemical formula for ammonium carbonate, okay, ammonium carbonate, which I think if I remember right, they might put no, they put ammonium chloride in some black licorice from Denmark. But ammonium carbonate is another ionic compound. So ammonium carbonate, its chemical formula to balance this, if I wanted to combine these two, I need 2 ammoniums to balance out the charge. Okay, I look at the upper right hand corner, the charge of carbonate is 2 minus. So since I have just a single, or that's 1 positive on ammonium, I need 2 of them. So if it helps, and I've been doing this in the video, you write it out however many times you need it. So I needed 2 NH4 pluses called ammonium to balance out 1 carbonate, right? And I just am double checking to make sure all the charges add up to 0. So to write this chemical, NH4 2 CO3, and I put the NH4 in parentheses because I needed 2 of them. So there's your examples. This will get you started. We'll do lots of practice in class. Thanks for your patience, and I'll talk to you guys.